Consider the organic formulae compounds below, and they've all been represented by condensed formulae. And actually, those are a bit horrible because you kind of have to puzzle it out. So I would have drawn all of those out. Most of you managed that quite well. So carrying on from there, select one of the compound that contains a double bond, and in drawing them out, you find that the only one that could possibly have a double bond between the two carbons is going to be C4 with 6 H's around it. Actually, there's not just one double bond, there's 2 double bonds. Then asks you to select one compound that is an ester and draw its structural formula. This double bond O in the middle of the molecule, this 2 O's in the middle of the molecule is what indicates that you've got an ester. And then if you're going to draw that out, you've got C2H5, C2H5. Then you've got a carbon which has a double bond O on it. Then it goes to a single bond O and then a CH3. Then it's select an alkane with less than 5 carbons and write down the equation. Well, an alkane has got only single bonds and between carbons and hydrogens. So there were 2 alkanes here. There was the C3H8, and then this molecule over here only had single bonds as well. But this has got 5 carbons in it, so you need to have less than 5 carbons. So it's going to be the C3H8. Then it says substitute with hydrochloric acid. So when you put the HCl on, 2 hydrogens will come off and an H and a Cl will go on. So it becomes C3H7Cl. Propanone is a ketone. You don't know much about ketones and aldehydes, but they can pop up if we don't go into too much detail on them. Reacts with iodine in the presence of an acid catalyst according to the following chemical equation. And there you've got the propanone, you've got iodine, and here you'll notice that one of those iodines goes on, and that means, and off comes a hydrogen. That means it's a substitution reaction. And explaining why that is so, you need to say the hydrogen comes off the propanone, and then the iodine goes onto the propanone. Petrol with an octane rating of 98 is made up of 98% trimethylpentane. The structural formula for trimethylpentane is given over here. Sorry, it's not. Yeah, it's 224 trimethylpentane. So what you can see over there is that there are 8 carbons altogether. Explain why that is saturated. If you take a look, it's only got single bonds, and therefore it is a saturated molecule. If you are given 2,2-trimethylpentane is an isomer of octane, which we've just realized. Explain what is meant by the term isomer. Isomer is simply a substance with the same molecular formula but a different structural formula. And then write the condensed formula for another branched isomer of octane. So you can't just do the chain of 8. There are a lot of different things that you could have done. You could have said, made this chain, instead of being 5, you could have made it 6 and then only had 2 methyl groups. You could have made it 7 and had only 1 methyl group. You could have made the main chain 6 and put an ethyl group on. So there are quite a lot of different ways of doing it. The way that I've done it over here is I have said that we've got 3, I've done 6 carbons, and then I've taken and put 2 methyls off, and I've named it. Number 3 has got a methyl group on, and number 4 has got a methyl group on, and so it's 3,4-dimethyl hexane. There were a lot of different options on that indeed. Then you're going to say the graph relates to the boiling points of alkanes and the number of carbons in an alkane chain. So as the number of carbons is going up, so the boiling point is rising as well. Businesses have lost money due to recent unexpected power outages in South Africa. Investing in alternative power supplies, such as generators, is important to avoid similar losses in the future. The preferred fuel for generators is diesel rather than petrol, because diesel produces more power per litre than petrol does. Diesel is composed of heavier hydrocarbons with at least 12 carbons per molecule. So what if I were to extend this, sort of carry on the trend of that line over there? When I get to 12, what is my boiling point going to be? And I can go across and see what that is. For petrol, you would go up at 8 and you would see what the boiling point was over there. Referring to the graph, describe the relationship between the boiling point and the number of carbons on the alkanes. The more carbon atoms, the higher the boiling point. Then read off the approximate boiling point of petrol. So reading off the approximate boiling point of petrol, I get about 125 degrees centigrade. And then if I am reading off the number for diesel, I'm going to go up there and go across, and I get to approximately 200. Explain fully the above trend in terms of the relative strength of the intermolecular forces between the molecules. Diesel is a larger molecule than petrol. Therefore, even though they're nonpolar overall, there are greater dipoles, instantaneous dipoles created, or greater electron wobble, and therefore you get greater intermolecular forces and therefore higher boiling points. So let's go through that one last time. Larger molecules have got greater instantaneous dipoles forming, therefore greater intermolecular forces and higher boiling points. The condensed structural formula of an organic compound is given below. If we take a look, we can get the longest carbon chain is over there, which means that we have got a chlorine hanging off, a methyl hanging off, and another methyl hanging off. So we've got a carbon chain that is 1, 2, 3, 4, 5. So it's going to be pent, something or other. Pentane, it's all single bonds. Hanging off that is a chloro. So we've got one chloro and it's off the first carbon. And then we've got two methyl groups. So it's 2, 1, 2, 3, 4, 5. So it's 2, 3 dimethyl pentane. The boiling point of a branched alkane is lower than that of a straight chain. Alkanes containing the same number of carbon atoms because branched alkanes have. What the branch is if you think about it, the branch has got a small surface area, whilst a long chain has got a big surface area. And therefore, there are more dipoles here because it's more spread out. And this has got less surface area, so it's more clumped together and has less dipoles. So taking a look at the options that were given to us in this one, smaller effective molecular surface areas. Larger molecular mass, if they are, for example, earlier we were just dealing with C8H18, we saw all sorts, that was petrol. We saw all sorts of different branches there. The molecular mass doesn't change with different isomers, so that's not true. Shorter chain lengths, the chain length containing the same number of carbons because branched alkanes have got shorter chain lengths. The chain itself is shorter, yes. However, the molecule has still got the same number of carbons, so that's a bit of a question mark. Let's look at it. More electrons, they have exactly the same number of electrons because they have the same molecular mass, but a smaller effective molecular surface, that is the reason that you have got lower boiling points. Ethene is a gaseous hormone associated with the ripening of fruit. It also contributes to the aging and distortion of plants. In industry, the artificial ripening of fruit takes place when ethene is passed over fruit in large rooms. After a while, the ripening fruit releases its own ethene. Write down the structural formula of ethene. It's 2 carbons with a double bond. Why is it not advisable to place a banana that has been artificially ripened alongside a cabbage or a lettuce? That banana will start making its own ethene and it will rot the cabbage and the lettuce, because after a while ripening fruit does make its own ethene. In industry, ethene is also used to synthesize all sorts of organic compounds. The flow diagram below illustrates many reactions that ethene undergoes. So, ethene is going to either become ethanol, ethane, or bromoethane. Let's see what we're going to do. Write down the general formula for the homologous series to which ethene belongs. So it's actually the alkenes, and the general formula for alkenes is CnH2n. That's the general formula. And then name the type of reaction represented by the letters A, B, D, and H, and write the letters A, B, D, and H and each type of reaction. So let's look at A. A is when ethane becomes bromoethane. That is going to be a substitution reaction. It is a hydro substitution, but we generally only use the word, we're going to usually just say substitution is enough. Then we have to look at B, and B is when ethene becomes ethane. So what am I doing? I am adding hydrogen there, and that is a hydrogenation. Then you have got number D, and D is when ethene becomes ethanol. That is again an addition reaction, and we're adding an OH onto it, and we're actually adding an OH and 2, so it is a hydration. I'm adding water onto that. And finally, looking at H, H is when ethanol changes into bromoethane. So the OH2 becomes a bromine, and that means that I'm going to put hydrogen bromide onto there, and it's a substitution reaction once again. Using structural formulae, write down the balanced equation for reaction B over there. So I'm going to take the ethene, and that's got the double bond in it. I'm going to add hydrogen to it, and it is then going to open up that double bond, and I will get ethane. And apart from ethene, which other reactant is needed for reaction F? So F is ethene, and we need to go to bromoethane. So again, I need to add hydrogen bromide to that in order to be able to get the bromine, a single bromine, onto the ethane molecule. If you have two test tubes containing equal amounts of X and Y, and they have the same number of carbons, you have to distinguish whether X or Y are saturated. You say that X is saturated, let's say. Design an investigation to show this hypothesis is true. Use the following to write down your design. Write only the question number next to your answer. Okay, write down your investigative question. Which of X and or Y is saturated? And I suppose that really did need a question mark. And then you're going to say, write down a list of apparatus and chemicals that you will use. So it's two test tubes. You would need, you could have said any alkane or alkene, but let's go with C5H10 and C5H12, and then some bromine. Then it says state safety precautions. Now bromine is carcinogenic, and often alkanes can have strong smells, so you would need a fume hood, obviously safety glasses, and a lab coat. Fume hood is a sort of a box that takes all the gaseous fumes away so that you don't breathe them in. Write down a procedure you could follow. You would add bromine water to both X and Y, and then you would shake them up. And then how do you know which one would be which? The quick color change would be the unsaturated molecule. In other words, it would have been the C5H10, and the one that keeps its color is the saturated molecule. And finally, write down the IUPAC name for compound Y, and that was a bit difficult because I hadn't anywhere told you that there were 5 carbons over here. But if I take it as 5 carbons, then you would have said that compound Y is either pent-1-ene or pent-2-ene, because compound Y is going to be your alkene. Alcohols are used in a variety of chemical reactions as preservatives in certain medicines. All alcohols are toxic. Although ethanol is the least toxic of all alcohols, it is still a poisonous substance. It is rapidly absorbed into the blood. High blood alcohol levels can cause brain poisoning. The body can reduce high blood alcohol levels by oxidizing it to the alcohol. Contrary to what people believe, alcohol is a depressant and not a stimulant. The following table indicates the effects of various blood alcohol levels. The liver enzyme ADH catalyzes the oxidation of ethanol into ethanol and then to non-toxic ethanoic acid. The liver is able to remove only 28 grams of pure alcohol per hour. Write down the names of the homologous series to which ethanol and ethanoic acid belong. So the ethanol is going to be the aldehydes, and ethanoic acid is a carboxylic acid. Write down the structural formula for ethanol, and ethanol is an aldehyde. You don't have to know them in detail, but to know that the oxygen is on the last carbon seems to be something that they can ask, even though it's not expressly in the curriculum. So it's CC with double bond O on the last carbon. Alcohols are prepared by the hydration, adding water, to alkenes. Use structural formula to write down the equation which represents the formation of ethanol. So I take an alkene, ethene, add water to it, and I get, the double bond opens up, and I get ethanol. The warning on the labels of certain medicines read as follows. The effect of this medicine is aggravated by the simultaneous intake of alcohol. Use the passage above to justify this. All medicines are processed by the liver. The liver does not cope with the medicine, so then the medicine is not effectively dealt with. If you put alcohol in, the poor liver is busy trying to make ethanoic acid and ethanol out of the alcohol. Medicines alter one's mental capacity, and so does alcohol, so all the effects are going to be increased because your body's just overloaded. The first 6 members of the alkanes occur in gases and liquids at normal temperatures. Alkanes are currently our most important fuels, but the use of alcohols as a renewable energy resource is becoming more important. Alcohols are liquids that might be the solution to the energy crisis. Which property of alkanes and alcohols make them useful? They are both combustible. The table shows the boiling points of the first 6 alkanes and alcohols, and they're given, and as they get bigger, that boiling point goes up. Alkanes have much lower boiling points than alcohols. You could put this neatly. I've just drawn a tiny little sketch over there. Draw a graph of the boiling points versus the number of carbon atoms for the first 6 alcohols. You would have had to have given a heading, graph showing the boiling points, etc. Choose 50 degrees and 1 carbon as the origin over there, and going up over there, and use an appropriate scale. Plot the points and put a best fit graph through. What trend in boiling points can be observed in the graph? That the more carbons there are, the higher the boiling point. Or you could also have mentioned the fact that the alcohols have got higher boiling points than alkanes. That's also a trend. Provide a reason for the trend mentioned in question 3 by looking at intermolecular forces. Well, the first one is the longer the carbon chain, you get stronger instantaneous dipoles since there are more electrons and therefore stronger intermolecular forces. Or you could have said that the alcohols are more polar, and that turns out to be the answer for the next one anyway. Explain, referring to the type of intermolecular forces, why boiling points of alcohols are higher than alkanes. The alcohols have got higher boiling points than the alkanes because the OH group is polar, the alkanes are non-polar, therefore alkanes have got weak IMFs, and the polar alcohols have got stronger intermolecular forces and therefore higher boiling points. People always caution to keep liquids such as petrol, which is alkanes, out of reach of children. Use the boiling points of alkanes to justify this. They have a low boiling point, so they can vaporize, which means you can inhale them, and then they can also burn very, very easily because they turn into a gas easily. You know that petrol has a very strong smell. That makes sense. Briefly explain why ethanol is a renewable energy source while the alkanes are non-renewable. Well, alcohols, ethanol, comes from fermenting fruit, and it can be remade all the time. Ethanol is a product of the fermentation, and we continue to make it from various plants, which we photosynthesize. That's all renewable, but alkanes come from oils and gas deposits, and therefore they will run out once we've taken them all out of the ground. And last question, hydrocarbons are simple organic compounds. The homologous series called the alkanes is one of those groups of hydrocarbons. One physical property of alkanes is shown in the table below. It's the boiling point over there, and when we've got isomers, the boiling points are going to change very slightly. Define the concept of homologous series. It has the same functional group, but increasing length of the carbon chain. Explain the change in boiling points of the alkanes from methane through to hexane. That is going to be an increasing boiling point. The more carbon atoms means there's more electrons, greater dipoles, greater intermolecular forces, higher boiling point. How do the boiling points of the straight compounds differ from that of their corresponding isomers? Give reasons. You can see that the straight ones have got higher boiling points than the branched ones. Why is that? Straight chains have higher boiling points because they've got a smaller effective, because there's a smaller effective molecular surface area on the bonded chains. So in other words, when I've got a greater surface area, I will land up with a greater boiling point, which is true of the straight chain. Talked about that a minute ago. The straight chain has a big surface area, whilst the branched has a smaller surface area. Low boiling point compared to high boiling point. Why? Because on this there's lots of electrons available to create dipoles here, very few electrons available on the outer surface area to create dipoles. Write down the structural formula for an isomer of hexane. There are a lot you could have done. It's an isomer of hexane in the table, so then the only one you can really do is 2-methyl-butane. So here's the butane, they're the 2-methyl groups on it. The human body secretes oils that maintain the moisture of the skin. Alkanes such as petrol and paint thinner dissolve non-polar organic materials such as oils and fats. So explain why people should minimize their contact with hydrocarbon solvents and paint thinners, because it's going to dissolve away the natural oils on your skin, and therefore your skin is going to be dried out and be vulnerable. It won't be protected any longer. Petroleum jelly, such as Vaseline, is a soft, semi-solid mixture of hydrocarbons that provides a protective film when used on the skin. It is hydrophobic. In other words, it repels water, and for example, you can use it on burns or to prevent nappy rash on babies. Which physical property of Vaseline explains why it does not flow like petrol? It has got what is called a high viscosity. It is semi-solid. It is thick and gloopy, so it doesn't run. We call that a high viscosity, and high viscosities result from high intermolecular forces because it all holds together very nicely. And finally, boiling water is accidentally spilt on a child. Explain why Vaseline should not be used on the child's skin immediately after those burns. It would stop the boiling water in the skin from getting away from the skin, and therefore it prevents perspiration, and all of those things would cool the burn. So it really shouldn't be used. You should leave that skin open to heal on its own.